Hello everybody, welcome to Statistics and Theory. I am Dr. Vahid Aryadust, and in this video I'm going to demonstrate how to do a reliability analysis using Jamovi. If you have now downloaded Jamovi, please go to Jamovi's website and download it from this link. I'll leave the link in the comments section for you so you can easily download it. In addition, there are three resources that I recommend to you. One of them is two book chapters in the Quantitative Data Analysis for Language Assessment book, Volume 1. In the first two chapters, my colleagues have discussed how to run Cronbach's alpha and how to interpret the results. Even if your field is not language assessment, I think the ideas are just common across all different fields where psychological measurement takes place. In addition to this website or this resource, I would like to recommend this wonderful paper. It's a sort of review and conceptual analysis of Cronbach's alpha and omega's values and their comparisons, which is just published in Communication Methods and Measures. It's really great to read. It provides a very useful and accessible introduction to both statistics, both McDonald's omega and Cronbach's alpha. In addition, you can read this paper as well. It's a Monte Carlo study of how to interpret the different values of Cronbach's alpha and McDonald's omega. And then finally this paper in Frontiers in Psychology, in which the developers at Jamovi talk about Cronbach's alpha and importantly McDonald's omega and their estimation in Jamovi. So it helps you to wrap your mind around the estimation methods of omega in Jamovi. I will leave all of these links for you so you can take a look and look at the different criteria and cutoff scores that have been provided and proposed by these scholars. Okay, so this is Jamovi. As you know, I have discussed how to open datasets in Jamovi in previous videos, so I'm not going to go through that again. The first thing we need to do is to make sure that we have this button here. It's called Factor. If you click on Factor, you see that in this drop-down menu, you have a few options, and the option that we're going to use is reliability analysis. Just click on it, and your first reliability analysis window will open. Now, if you cannot see Factor here, you should go to Modules, click on Modules, click on Jamovi Library right on top, and under Available, you should be able to find Factor. And once you've found it, just click on the button Install. It will be installed automatically. But my understanding is that in most versions of Jamovi, Factor is there by default. Okay, now I assume that you have already downloaded Factor. You can see it on the toolbar. So please click on it and click on Reliability Analysis. Once you click on Reliability Analysis, this window opens. Okay, and I need to, because I have done this before, I need to refresh the interface and do it again. Right, the first thing I would like to show you is that if you run a reliability analysis, regardless of whether it's Cronbach's alpha or McDonald's omega, on items that are not otherwise related to each other, you will get a very small index of reliability. Okay, so I'm going to move these few items to the right-hand side, item 1 all the way to item 5, and click on this arrow. Now, I've moved everything to the right-hand side, and as you see, the Cronbach's alpha value is pretty small, 0.0302, which is almost nothing, which is close to 0. Now, before I go ahead, I should also add that I am recording this video from home, and today there are a lot of birds and crickets chirping and making sounds. If you hear them in the background, I hope they're not too loud to distract you. Anyway, it's one of the cool things about the campus, the university campus where I'm living, the Nanyang Technological University. As you see, this Cronbach's alpha value is very small. And as I was saying, this is an indication that these items are not internally correlated or related to each other. In other words, they might be measuring different constructs. So the first thing is this. The items should be related to each other and should measure the same construct. Now, this questionnaire has a number of items. Let me just refresh the browser again, the interface again. It has 23 items, and it's meant to measure fear of statistics and mathematics. And these are the items. 23 items in 4 factors. The first factor, which is fear of math, is measured by these 3 items, items 8, 11, and 17. So what I would like to do is to move item 8, 11, and 17 items. This is 8, 11, and 17 to this interface here to get the Cronbach's alpha value, which is now very strong. It is well above 0.7 and certainly above 0.8, which indicates that I have got a good Cronbach's alpha value. I will also provide you with some information about how to interpret Cronbach's alpha, but let's first learn how to run the analysis before we talk about how to interpret them. Okay, so that's step 1. In step 2, you'll see the box here beside McDonald's omega. Just click on omega to get omega right beside Cronbach's alpha. In most analyses that I have personally carried out, Cronbach's alpha and McDonald's omega are very close to each other. In some analyses, they're even exactly the same. But there are some scenarios in which it's better to use McDonald's omega, and that is something that I'm going to explain in a minute. Now, if you're interested, you can get the mean and standard deviation of the entire measures that you have. In this case, you've got 3 indicators, so we will get the mean and standard deviation of all 3 indicators in this box. Now, for item statistics, I suggest that you take a look at Cronbach's alpha if item is dropped, especially if you are looking at a scenario in which the Cronbach's alpha value is small. And if it's small, one of the diagnostic measures that you can take is to look at Cronbach's alpha if item is dropped, if any of the items is dropped. In this case, of course, our Cronbach's alpha value is really good, so I don't want to get anything lower than this. But for demonstration, I'm looking at this table here. If item dropped, Cronbach's alpha will also drop. So in this case, I've got item number 8, which if it is dropped, Cronbach's alpha also goes down to 0.74. Do I want to drop item 8? Not really, because I've gotten a much better Cronbach's alpha in its presence. In its absence, I would have a Cronbach's alpha of 0.74. Again, in the absence of number 11, my Cronbach's alpha value, as you see here, will go down to 0.742. And in the absence of the last item on the scale, a Cronbach's alpha value will still drop. So I don't really want to do that. How about McDonald's omega? Is it a good idea to drop any of the items to get a better McDonald's omega? You'll see no. The story is exactly the same. If you drop any of the items, Cronbach's alpha will drop to something exactly the same as Cronbach's alpha if those items were dropped. Okay, then what will happen to the mean and standard deviation if those items are dropped? So if the first item is dropped, mean and the standard deviation will drop to these, or will change to these actually. The mean will drop, but the standard deviation will increase. This is not a good thing, to have a smaller mean but a larger standard deviation. Whereas here, the mean is, to have a smaller mean here. But this mean here is larger than this, but the standard deviation is smaller than this, and this means that there is better internal consistency. This is just one telltale indication that the consistency internally is probably better than here, but the best index to indicate internal consistency is actually Cronbach's alpha and of course omega. Now, do you want to get correlation heat map? I personally do, so why not clicking on the additional options, correlation, heat map, and get the correlation statistics of the items in the form of a heat map. And I'm really glad to see that the correlation statistics are large. Anything that is around 0.5 is medium, and it's pretty much good for us. So as you see, all of these correlation statistics are well above 0.9, 0.5, and this is 0.59, 0.59, 0.63, which is pretty good. So this is another diagnostic information for us, just in case you find that Cronbach's alpha value is small. You can also consult with this table, and if you see that there are some weird correlation statistics, you can drop them from the analysis. You can drop those items from the analysis. Now, if some of your items need to be reverse coded, just click on this option and you can reverse code any of the items that you want. In this analysis, I have used 3 items, as you see, so any of them could be reverse coded. And by reverse coding, I mean, for example, 1 or 2 or some of the items are negatively worded, whereas the rest of them are positively worded. In this case, the negatively worded items should be reverse coded. Otherwise, you will get a very small or even negative Cronbach's alpha value. Now, if you are interested, you can save the mean score per person and the sum of scores per person as well, which in this case I don't want to do that because I don't need it. Okay, now so far I have just showed you how we can run a Cronbach's alpha and McDonald's omega analysis in Jamovi. Now let's go through some more theoretical discussion of what these statistics mean and how to interpret them. First of all, Cronbach's alpha, which was developed in the early in the 1950s by Cronbach, has advantages, quite several advantages over earlier methods of reliability analysis, such as split half and Coulter-Richardson. One of the advantages that you probably have read in many books or papers that are about Cronbach's alpha is that it's an average of all possible split half reliabilities, because you know, if you want to run a split half reliability analysis, you have to divide them divide the items into 2 halves and then run the analysis on those 2 halves, meaning to correlate them with each other and to get a reliability index. But in this case, you know, it's possible to create different types of halves. You can split the items in different ways. So Cronbach's alpha provides you with a value that's an average of all possible split half reliability statistics. That's a good thing about it. So you don't have to keep splitting the data and running the reliability analysis again and again to see how reliability changes. It's suitable for dichotomous items, but also for polytomous items. In my previous experience, I have noticed that when you have got dichotomous items, Cronbach's alpha tends to be a bit lower compared with polytomous items. So it's a good idea to always consider whether your test items or your questionnaire items are dichotomous or polytomous. If they are dichotomous, expect that the value may be smaller than what you would expect. But in any case, both Cronbach's alpha and McDonald's omega are suitable for the reliability analysis of dichotomous and polytomous items. The next thing I would like to share, and I'm going to go through this a bit fast in the interest of time, is some facts about Cronbach's alpha. One of the facts is that because it's based on the CTT, or the classical test theory, if your construct is narrow, in other words, if you have only a few items to measure your construct, you would probably get a low Cronbach's alpha, especially if your scale is dichotomous. Now, with polytomous items, with a good discrimination of the items, even if you have just a few items, like 3 or 4 items, there's a high likelihood that your Cronbach's alpha value will be high. Just like the example I showed you, because the discrimination is good. In other words, there is a good match between the item difficulty and people's ability or the latent trait levels, then Cronbach's alpha will return a good internal consistency coefficient. The second point that I would like to share is broad constructs with many items generally, but not always, but generally provide you with high Cronbach's alpha statistics. Number 3 is Cronbach's alpha depends on average item correlations. As I showed you before, you can run a correlation analysis. If the correlation between your items is high, among all of the items, I mean, not just one or two, then there's a chance that you will get a higher index. So if your data is not normally distributed, or if it's skewed, that affects the correlation, and the low correlations can also affect your Cronbach's alpha value. So low item discrimination, as I mentioned before, results in low reliability statistic. I don't want to talk about item discrimination in this video. In the item response theory video, I have talked about item discrimination. If you're interested, please watch that video. I'll leave the link of the video in the comments section of the current video. So there are other factors that can affect Cronbach's alpha. If your measurement errors of each item are correlated, then I'm afraid the Cronbach's alpha value will probably be small. By that I mean, if you are, as an example, if you are measuring factor 1 or whatever, construct 1, with 3 items that I just showed you, for example, it was item 8, item 11, and item 17. To each of these factors is attached an error of measurement. Right. Cronbach's alpha analysis by default assumes that there is no correlation between these 3 errors. But in fact, there are many scenarios in which errors, which are basically residuals that are not explained by the main factor, are correlated. And you can test for this through a confirmatory factor analysis model. In the confirmatory factor analysis model video, I have discussed this, right? So if you feel, or if you have evidence that these errors are correlated, and then you see that your Cronbach's alpha is small, it might be due to the fact that, well, your errors are correlated, and there might not be a very big issue with the data set. In this case, Cronbach's alpha might not be the best case for you, the best reliability index for you. I would recommend that you use McDonald's omega, and there are 2 types of McDonald's omega, as you see here at the bottom: hierarchical coefficient and total coefficient omega. The hierarchical one is useful for multidimensional scales, and the one that I used in this video, and the one that is produced by Jamovi under the factor module, is the total coefficient omega, which is suitable for unidimensional scales. But if you have a multidimensional scale, let's say factor 1, as you can see, factor 1 here is correlated with factor 2, etc., then in this scenario, it's a better idea to use the hierarchical coefficient omega, which is actually generated in the structural equation modeling module of omega, which I have discussed, of Jamovi, which I've discussed in 4 videos on structural equation modeling. Please watch those videos for further information about omega, and of course other information that's related to internal consistency and psychometric reliability when it comes to SEM, or structural equation modeling, in Jamovi. Okay, so the next fact, or the next piece of information that I would like to share, is that low values of Cronbach's alpha always indicate that it's not a good idea to compute a sum score. And the reason is that these items might be measuring different things, and that's why they have no internal consistency. So if you're a teacher, and if you are going to return the test scores to your students, before adding up everything and creating some scores per each student, it's a good idea to look at the Cronbach's alpha value of your tests. Or if you have some evidence that the error terms are correlated with each other, run a omega coefficient analysis on your tests to find the internal reliability statistic of your items. Now, just a few words about McDonald's omega. Like I said, Cronbach's alpha makes strict assumption, and one of them is that there is no error correlation, as I mentioned before. Now, there are two other assumptions about Cronbach's alpha. So if you're using Cronbach's alpha, you need to make sure that your scale is unidimensional. I've talked about unidimensionality in quite a few videos before. In addition to that, Cronbach's alpha always makes the assumption that there are equal tau coefficients or equal factor loadings. I'm going to go back to the previous slide. By tau coefficients, I mean the factor loadings that you will see on confirmatory factor analysis output, and they're usually here. It's also known as beta or regression. So it's beta 1, beta 2, beta 3, or regression coefficients. As you see, if you have done CFA, or as you have seen probably in my videos, it's really very difficult, if not impossible, to get exactly the same or even similar tau coefficients or beta coefficients in CFA. So most often when we are running Cronbach's alpha analysis, one of these assumptions, that's assumption 2, is actually easily violated. In this scenario, it's a good idea to use McDonald's omega, and if McDonald's omega total. But if your instrument is multidimensional, it's a good idea to use hierarchical omega because it's more suitable for multidimensional data sets. So if any of these assumptions is not met, I suggest that you use the omega. But as I will describe later, most often the two values are very close to each other. Of course, there are exceptions too. Now, how do we interpret Cronbach's alpha or omega? There is some more research about interpreting Cronbach's alpha. For example, Tabor's publication in 2016 provides this beautiful table to summarize the findings of the review study that has been carried out in the paper. As you see, there is almost no consensus over what is the best range and how to call those ranges. For example, the range between 0.93 to 0.94 has been referred to as excellent. A similar range has been referred to as strong, and some authors have referred to 0.84 to 0.90 as a reliable range for Cronbach's alpha statistics, and so on. Now the question is, which one of these ranges is acceptable and which one we should use? Again, I should say this is a subject of contention. It depends on many factors. But what I would recommend as a kind of rough solution, maybe something that many people, if not everyone, agree with, is right in this slide. If you really are doing some sort of high-stakes decision-making using some psychometric tests, it's very important that your Cronbach's alpha values are high. Certainly something about at least about 0.8 and definitely 0.9 and above will provide you with higher certainty and precision about the claims that you want to make using your data and using your instrument. Now, this range is something that is agreed upon by some people, by some scholars, but not probably everyone. So the values between 0.1 to 0.3 is poor, 0.3 to 0.5 is low, 0.5 to 0.7 is medium, and 0.7 to 1 is high or strong or excellent. You can refer to it by different names. And there are alternative methods which I have discussed: rush measurement and G-theory analysis. I've discussed rush measurement way of doing reliability analysis in many videos before. Feel free to watch those videos if you think that you're interested in that concept as well. Now, two last slides here, I think they're quite helpful, especially since they shed more light on the interpretation of McDonald's omega and when and how to use it. This is from this paper. I will leave the link to the paper from McNish. McNish says that Cronbach's alpha is a special case of omega that requires a restrictive assumption that's unlikely to be met in many measurement situations, which I just mentioned before. I'm sorry, this is from Hayes and Coutts. I just revised myself. This is just an additional paper for you to read. Hayes and Coutts paper I just showed before. This is the the citation of the paper. They go on to say that thus clinging to alpha because it's easier to calculate is an untenable position to take. So what they recommend is, however, anyone who adopts this recommendation, in other words, they recommend that it's a good idea to use omega, will eventually discover something that we should be honest and open about. While the methodology literature has demonstrated that omega is clearly a superior and preferred measure of reliability relative to alpha, in our experience, the two measures typically produce similar estimates of reliability. And I totally agree with this because I have looked at Cronbach's alpha values and omega values in many analyses, especially those analyses where the instrument is unidimensional, and I see that they are either the same or very similar to each other when applied to real data. But when you have got multidimensional statistics, you can see that the differences between the two widens. In those cases, it's a good idea to rely on McDonald's omega. And now it's actually easy, if in the past it was not easy to calculate omega, McDonald's omega, with Jamovi and even other packages like SPSS. The latest version of SPSS is now it is 28, version 28. It provides omega, and also JAS, which is another free software. It also provides omega. So it's much easier nowadays to run McDonald's omega and compare it with Cronbach's alpha statistics. And last but not least, it's from the other paper which I introduced before, is about how to interpret omega, not just Cronbach's alpha, but omega. I've highlighted this section, so I want to quickly read it to you, and that will be the end of this presentation. This paper suggests that for unidimensional measures, alpha and omega t, that's total, above 0.8 are very likely to produce high entropy. So this is an index of fit. The higher it is, the better it is. And so it leads to a much higher likelihood of good distinction between a poor and the not poor. And in this context, what the author is comparing is people who are poor and people who are not poor, where the classification error is smaller than 5%. For multidimensional measures, okay, with well-defined dimensions, the recommendation following the contemporary literature is to avoid alpha and use hierarchical omega. So what index of hierarchical omega? Hierarchical omega of above 0.65 according to this study. And anything that is a hierarchical omega plus a total omega which is larger than 0.8 are the very minimum expected for a poverty index that differentiates between poor and the not poor. And this is just not only specific to those measurement instruments that are about poorness and measuring whether some families or some people are affluent or not. In my view, it can be applicable to other contexts as well. So I'll leave this and the link to this paper for you. If you have some time, please feel free to go through it. I'm sure that you'll find more interesting stuff in that paper about both Cronbach's alpha and omega. So this brings me to the end of this video. I hope you find it useful, and if you do, please give it a like, and have a good day.